Today, we'll learn about a powerful data structure in programming called arrays. It's something you'll use in almost every coding project, from games to websites to data processing. Let's imagine this. You have a bookshelf with 10 compartments. You decide to place one book in each section. Later, if someone asks you, "Where's that book 3?" you instantly say, "It's in section 3. That's exactly what an array is in programming. It's like a bookshelf where each compartment holds a value, and you can easily access any item using its position, which we call an index. An array is simply a collection of similar elements stored together in an ordered way. Think of it as a row of containers, each capable of holding one item of a specific type, like numbers, names, or scores. Now here comes the question why we use arrays. Imagine having to store the marks of 100 students. Creating 100 separate variables would be messy and inefficient. Instead, with just one array, you can organize all of them in a neat, manageable way. In arrays, indexing starts from 0, not 1. So if we say index 4, we're talking about the fifth item. Why start from 0? It's not just a random choice. There are performance and memory reasons, but we'll park that for now. There are multiple kinds of arrays, not just one. Some have only rows while some have rows and columns both. One-dimensional array is like a single row, which is simple and linear. Two-dimensional array is like a chessboard, which have rows and columns. Multi-dimensional arrays go even further. Think of a Rubik's Cube or spreadsheets with tabs. We use 2D arrays to represent matrices, images, maps, or even game boards like Sudoku. Arrays help us structure data in memory just like we experience the world: organized, sequential, and retrievable. Let's dig a little deeper. When we create an array, what we are doing is basically reserving a continuous block of memory, like booking a row of hotel rooms side by side, instead of scattered all over. Why is this important? Because it allows super fast access. If I know the address of the first room, and each room is exactly 5 meters apart, I can directly reach room 4 without asking anyone in between. This is called direct indexing. It's what makes arrays super efficient for reading data, which is much faster than other structures. Once we have our array, let's see what operations can we do. First is access, which means we can instantly get any element by its index. Second is update, which means we can simply change or update the value at a specific index. Third is insert, which basically means adding a new element, which can occur only in dynamic arrays. Fourth is delete, which simply removes an element, might need shifting. Each of these actions varies in performance. For example, accessing is instant. What about inserting the element in the middle? It takes time as you need to shift others. Now let's be real, it's true arrays are powerful, but they have their weaknesses. First is they have fixed size, which means once declared, the size can't be changed unless it's dynamic. Second is that all elements must be of the same type. Third is insertion and deletion, which is tricky and slow if you do it in the middle. That's why in real applications, people sometimes move to more flexible structures like lists or linked lists. But arrays are still the foundation. Now here is cool concept: static versus dynamic arrays. A static array is like booking 10 seats in a theater, even if only 5 people are coming. The rest stay empty, which will be considered as wasted space. On the other hand, a dynamic array is smarter. It starts small and grows only when needed, like adding more plates when guests arrive. Dynamic arrays are used in many high-level languages under the hood, like Python's lists, Java's ArrayList, or vectors in C++. In machine learning, image data is handled as multidimensional arrays. Each pixel, each channel is an element. In web development, user data, product lists, chat histories all rely on arrays behind the scenes. In finance, time series data like stock prices are stored and analyzed using arrays. In games, arrays manage everything from player stats to enemy positions. Arrays are everywhere. Once you see it, you can't unsee it. Arrays are the first true data structure you learn, and for a good reason. They train you to think in sequences, understand memory layout, and apply logic efficiently. If you truly understand arrays, you've already taken the first big leap into the world of algorithms, optimization, and real-world software development. Thanks for learning with me today. You didn't just learn about arrays, you understood them from the ground up. Till then, keep practicing, stay curious, and remember, mastering the basics is your superpower.